And as you can see, we have reduced the number of papers down from some 770 something to about 419. And we want to see who's been working in this particular subset of papers that we have in this application in X-ray astronomy. And we can see that the top authors here, there's Brandt, there's Shartis, and so on and so forth. Just for kicks, we may want to go down and see who's been doing most of the proposals that have gone into this specific field. And you can see that Gamire Gordon has 39 proposals, Steve Murray has 40 proposals. Let's go and filter this stuff down further, and let's actually look for people who worked on CFERTs, CFERT 2s here. So there are 153 papers which have CFERT 2s. We click on that. And we get 153 papers on the right side. So we're looking at X-ray astronomy and CFERTs. And we can see that the top authors now have changed. M. Hardcastle is really active in this particular field. And we can see the proposals that went into this. Gamire Gordon's gone down in the number of proposals here, and Steve Murray, there are still 18 proposals. And so let's actually go for Steve Murray's proposals here. And we have now got it down to 18 papers, and we get it down to 18 papers. You can go and look at the authors out here, and you can see that, as you might expect, Steve Murray has probably written most of the papers which have anything to do with this, but there are a lot of other people he's collaborated with, like Hardcastle, and maybe there are people who have written papers on their own on this subject. And you can thus, actually go about and find out everything about a particular field using this user interface. And we can do other stuff with this. So for example, maybe we only want to find out stuff that's happened using MAST. So we click on MAST on the data facets, and we get down to 33 papers here. Now, of course, MAST has many more papers, but in this particular prototype, we only have data from HUT, which is a ultraviolet mass emission, as you can see, probably seeing the top keywords over here. And let's say we actually want to reduce the amount of time. In fact, let's say we only want the second HUT instrument. So there we go down to 22 papers. With those 22 papers, we may want to choose a particular target, supernova 1006. And now we have the observation IDs, we have the 2 papers, and for each of those papers, you can see more information, the data sets. You can go click on the data sets. This will take you to the MAST site. Very soon, we'll have the ability for you to be able to download all these data sets, and you'll be able to download this either to your local file system or to a VAO space when the VAO space protocol is available for us to use. Anyway, I hope I've kind of made it clear that you can use this application both for just exploring the field and trying to figure out which authors to follow and stuff like that, as well as actually going and getting the data that you want, mediated, if you like, by papers. In the multiple tabs, you can do the search in different fashions. So on the publications tab, which we were at right now, we did the search mediated through publications, but you could do the search mediated through objects. If you knew more about the data sets, you could do the search mediated through data sets. If you wanted to find out more about the proposals that went in, because you might be interested in what else you could do with the data that came from the proposals, you could do that too. And in all of this stuff, remember that you'll be able to download the papers, download the information, bookmark authors, bookmark publications, bookmark data sets to see what happens, and keep track with these publications and data sets as time goes on. To conclude, I'd like to mention that the underlying metadata store captures the main aspects of research and curation activities, and it captures all of this with provenance. You can see in this screenshot taken from a paper that Alberto Acomazzi and I published at ADAS that we try and capture everything. We capture the proposal stage, the publication stage, the analysis stage, and the observational stage in this semantic triple store. Once the information is stored in the triple store, it's then removed by asking questions on the data, and the answers are stored in an indexing server. This indexing server is used to populate the user interface, and the results of both the indexes as well as questions asked in the triple store, as I said earlier, are made available to other applications so that more interesting astronomy applications can be built in the future. Thanks for listening.